Hello physicists, I'm out here this week to introduce the topic of thermodynamics, which is going to be what we're studying this week. And this is really the chapters that connect what's happening that we can measure in the macroscopic world out here to the microscopic motion and activity of the atoms that are inside of stuff. And so I came out here today to talk a little bit about thermodynamics and equilibrium and to introduce a new concept of energy called heat. So let me just flip this around real quick. So I'm out here at our compost heaps, and this is what we do with all of our horse manure. I take the horse manure and I put it in this far bin over here. After about a month, I flip it into that bin. After about another month, flip it into that bin, and then finally after about 3 or 4 months we flip it over here into this bin, and this becomes usable compost for the garden. And I just wanted to point out some interesting stuff about this. First of all, let's take a look at this thermometer I have in here. You can see that it's reading about 30 degrees centigrade, which is roughly about what the temperature is out here. And this compost is more or less done doing its decomposition, and it's just basically a pile of dirt that's in thermal equilibrium with its surroundings. So it's about 30 degrees C out here, and that mound is about 30 degrees. So I use those words thermoequilibrium, and that means that the temperature of the material inside the heap is about the same as the temperature outside, and there's no net heat transfer between the two. Now, of course, that begs the question, what do I mean by temperature and what do I mean by heat? Temperature is basically a measure of the internal movement of the molecules of a substance. So all substances have some kind of internal motion, and that motion is effectively kinetic energy, and that the jostling of all those atoms together is something that we can quantify with temperature. But when I'm talking about heat, what I'm talking about is the transfer of energy from one object to another. And we know that this always happens from hot objects to cold objects. If I put a pot of hot water on the counter, it will cool down to room temperature. If I take room temperature water and put it in the freezer, it will cool down and freeze into ice. And that's the heat flowing from the warmer object to the colder object. And this is something that happens spontaneously. It never happens in the other direction, that we have heat flowing from a cold thing to a hot thing, unless we're doing some process which is forcing that heat energy to go from the cold thing to the hot thing. It never happens spontaneously. So I came out here to my compost heaps because I can get a hint as to what's going on inside of them by measuring the temperature. Okay, so here's another compost heap, and I'm going to go ahead and plunge this thermometer in here again and push it way down in there. And we're going to give it a minute to come up. And you can see that where that other heap was reading 30 degrees C, this is actually getting close to 55, almost 60 degrees centigrade. So what that means is that it's hotter inside that heap than it is in the surrounding environment. And because of the basic laws of thermodynamics, that means there has to be something going on in there that's generating energy, making it hotter inside than it is outside, and now the heat is flowing from the hotter object to the colder object. And of course, that thing in there is metabolism of microorganisms. The microorganisms that grow in the horse manure are in an environment where they can metabolize and generate energy, and that energy heats up that pile of compost and makes it hotter inside than outside, and then that's going to make it dissipate to the surrounding environment. So by measuring the temperature, I know that something has to be going on in there, because it's a much, much higher temperature, nearly twice the temperature of the heap that's the same as the outside temperature. And that tells me that I'm actually cooking my compost. So this heap is not quite ready yet because it's still cooking. It's still at about 60 degrees C, which is ideal for the decomposition I'm looking for. And my microorganisms are busy at work. And I'll know that they're done when the temperature on the inside of that reaches the ambient temperature. And then I know that I can flip that heap and use it on my garden. So this week you're going to be looking at how energy and heat interact with each other, what heat energy is and how it interacts with other objects. And you're going to be looking at how your body uses energy and generates heat, as well as generating useful work that you can do stuff with. We're going to be looking at the connection between those concepts and the microscopic nature of matter and how that equates with pressure and temperature and things that we measure in the macroscopic world. So that's what you're going to be doing this week, and I will look forward to talking to you later.